Thanks. Welcome to Winnie Luna Nahial Eduk channel on mathematics and other related topics. In this video, we are going to discuss about measures of variability. Measures of variation. We have discussed measure of central tendency to describe the distribution of scores. However, the measure of central tendency does not uniquely describe a distribution. Most especially, if we want to know how close or how far is the distance of the scores of students in a certain test from the average performance of the group. It is in this line that we make use of the measures of variation. Measure of variation is a single value that is used to describe the spread of the scores in a distribution. The term variation is also known as variability of dispersion. There are several ways of describing the variation of scores, absolute measures of variation, and relative measures of variation. Let us consider the scores of students in three sections of mathematics class. We shall consider the spread of the scores based on graphical presentation. Now, look at the test scores. We can see that the mean of the scores of the students in the three sections are the same. The mean is equal to 18.25. Now, the standard deviation for section A is 5.15. The standard deviation of section B is 6.92. Section C has a standard deviation of 7.63. Now, these are the informations we got from the test scores of the students from section A, section B, and section C. Here, we can see the diagram of the table. You can see the dispersion of the test scores. You can see the spread of the test scores. And we're going to answer the following questions. What can you observe about the mean and the standard deviation of the three groups of scores? Which group of students perform well in the class? Which group of scores is most widespread, less scattered? And before answering such questions, let us first discuss the different types of measures of variation. Now, types of absolute measures of variation. We have four kinds of absolute variation. We have range, interquartile and quartile deviation, mean deviation, and the last one, variance and standard deviation. Now let's have range. Range is just the difference between the highest score and the lowest score in a distribution. Range is the simplest and the crudest measure of variation. Simplest because we shall only consider the highest score and the lowest score. So given the data points, all you have to do is pick out the smallest score or observation and also the highest observation. So take their difference, subtract the smallest observation from the highest observation. That is your range. Range for ungrouped data. So you have it. R equals highest score minus lowest score. Where R, the range value, H is the highest score, L is the lowest score. Example, find the range of two groups of score distribution. This one, we have Group A, in which the lowest score is 10 and the highest score is 30. Then Group B, the smallest score is 15 and the highest score is 30. So for Group A, the range is 35 minus 10, and that is equal to 25. For Group B, we have 30 minus 15, that is equal to 15. Now, the analysis says that the range of Group A is equal to 25, is greater than the range of Group B, which is 15. The implication of this is that scores in Group A are more spread out than the scores in Group B, or the scores in Group B are less scattered than the scores in Group A. So the higher the range, it can be assumed that the observations, the test scores, are more spread out. So that is our idea if the range is too high. Range for group data. For the range of group data, you have the highest score upper boundary minus the lowest score, or that is the lower boundary. So again, R is the range value. It says you be the upper boundary of the highest score, LSLB, that is lower boundary of the lowest score. Now we have here an illustration. Find the value of range of the scores of 50 students in mathematics achievement test. Now, the test scores of the students are presented in this illustration as group data. Our lowest category is 25 to 32, and the highest category is 89 to 97. The number of observations is 15. So for 25 to 32, for that category, there are 3 students who got scores within that class interval, or within that group of scores. So the lower limit of the lowest score is 25. So the lowest score, lower boundary, is 24.5. We have this in our previous discussion, that to get the lower limit or lower boundary, you have to subtract the lower limit by 0.5. And the upper limit of the highest score is 97. So the upper boundary of the highest score is 97.5. So the range would be 97.5 minus 24.5. So the range here is 73. Now, properties of range. It is the simplest measure of dispersion, as what we learned earlier, that range is the simplest measure of dispersion, because you only have to get the lowest score and the highest score. And in the case of group data, you have to consider only the lower boundary of the lowest score and the upper boundary of the highest score. It is quick and easy to understand, of course, because you just take the difference. If the range is too high, we could understand that the more spread out the scores, the observations are widely spread. It is a rough estimation of variation. It is easily affected by the extreme scores, of course. Then it fails to communicate any information about the clustering or the lack of clustering of the values between the extremes. Okay, so we do not have an idea about the clustering of the observations. How far are they from a point of reference? We do not have that kind of information. Again, that is because we only have the difference of the highest score minus the lowest score. Interpretation of range value. When the range value is large, the scores in the distribution are more dispersed, widespread, or heterogeneous. So that's what we're talking earlier. On the other hand, when the range value is small, the scores in the distribution are less dispersed, less scattered, or homogeneous. Now, let's have interquartile range, IQR, and quartile deviation. Interquartile range is the difference between the third quartile and the first quartile. So IQR is equal to Q sub 3 minus Q sub 1. Now, properties of interquartile range reduces the influence of extreme values. That is true because we are only after of getting some information at the middle 50 of the observations. Not as easy to calculate as the range. Well, there's some calculations that you will do to be able to get the interquartile range. Only consider the middle 50% of the scores in the distribution. This is the reason why extreme values do not affect the interquartile range. The point of dispersion is the median value. Now, quartile deviation indicates the distance we need to go above and below the median to include the middle 50% of the scores. It is based on the range of the middle 50% of the scores instead of the entire set. So in this quartile deviation, we only consider the middle 50%. Again, this is the reason that extreme values do not affect the interquartile range or even the quartile deviation. The formula in computing the value of the quartile deviation is this one. QD equals, or quartile deviation is equal to Q sub 3 minus Q sub 1 divided by 2. Where QD is the quartile deviation value, Q1 is the value of the first quartile, and Q3 is the value of the third quartile. Now, steps in solving quartile deviation. So first, solve for the value of Q1, solve for the value of Q3, and solve for the value of QD using the formula QD equals Q3 minus Q1 all over 2. Now, quartile deviation of ungrouped data. So you have this formula QD equals Q3 minus Q1 all over 2. Now, let's have an example. Using the given data, 6, 8, 10, 12, 12, 14, 15, 16, 20, find the quartile deviation. Okay, so first, we have to solve for Q1 and Q3. Okay, so we have here 9 observations and these observations are already arranged. So again, we already discussed this formula in our topic about point measure, about quantiles. So the first quartile, so Q1 is equal to 1 over 4 times n plus 1 minus 1/4 times the nth score. Again, we're talking in group data here. Now, you substitute n by 9 and then multiply that by 1/4. Then 1 minus 1/4. Again, that 1 can be written, this 1 can be written as 4 over 4. Then copy the common denominator. Then 4 minus 1 is 3. So this becomes uh, 12 over 4 because 9 plus 3 is 12. So this is equal to the third score of the observation. So that is equal to 10. So third score, 1, 2, 3. So 10 is the third score in the given data set. Then solve for Q3. So we simply use the same formula, but our uh, indicated quartile is 3. That's why we have 3 over 4. So the same process here, that is 3 also because our indicated quartile is third quartile. So substituting, we get 27 plus 1, that is 28 over 4. That is the seventh score. Seventh score. So what is the seventh score here? 1, 2, 3, 4, 5, 6, 7. So the seventh score is 15. Now, the interquartile range is equal to Q3 minus Q1. So you have 15 minus 10. So that is your interquartile range, which is 5. Then for the quartile deviation, you have to divide your interquartile range by 2. So you get 15 minus 10 divided by 2. You have 5 divided by 2. So that is 2.5. So our analysis here, the amount of deviation from the median value is 2.5. Next, we have here another illustration. The data given below are the scores of 50 students in Filipino class. Solve for the value of the quartile deviation. So we have here this one. So this is now a group data. So we have to solve for Q1. So our end here is 50. Then divided by 4, you have 12.5. So Q1 or the quartile 1 class interval is 41.48 because this 12.5 is less than 15. Okay? So we have to recall our lesson in point measures. So our lower boundary here is 40.5 because the lower limit of this category is 41. So subtract that by 0.5. So it becomes 40.5. Then the cumulative frequency before the quartile class, so before 15 is 10. Then the frequency of the quartile class is 5. Then the class interval is 8. So Q1, again, this is the formula. Substitute. So you have 40.5. Then this n over 4 is substituted by 12.5. Then CFP1, that is 10. Then the frequency is 5. So you have the calculation. Then you get 44.5. So that is our Q1. Q1. Then solve for Q3. So the same formula. But this time you have to what's this? Substitute n by 50, but you have to multiply that one by 3 because our intention is to get the third quartile. So 3 times 50, that is equal to 150 divided by 4, you get 37.5. Now look at the cumulative frequency. That is less than 45. That is less than 45. So our quartile class is 73 to 80. So our lower limit is 73, so the lower boundary is 72.5. Then the cumulative frequency before is 37. Then the frequency of the quartile class is 8. Then the class interval is 8. So again, use the formula, do the substitution and the calculation. You will get 73. Okay, so we got Q sub 3. So our interquartile range would be 73 minus 44.5 because we cannot get the quartile deviation unless we have to get the interquartile range because we divide the interquartile range by 2 and the result would be our quartile deviation. So you have it there. Okay, 73 minus 44.5 divided by 2, you get 14.25. Okay, let's now come to the interpretation of interquartile range and quartile deviation. The larger the value of the interquartile range or the quartile deviation, the more dispersed the scores at the middle 50% of the distribution. On the other hand, if the IQR or interquartile range or the quartile deviation is small, the scores are less dispersed at the middle 50% of the distribution. The point of dispersion is the median value. Okay. Analysis for interquartile range and quartile deviation. When the value of IQR and QD is small, the scores are clustered within the middle 50% of the score distribution. On the other hand, the scores are dispersed in the middle 50% of the distribution when the value of IQR and QD is large. To determine which group of distribution is more clustered or dispersed, you should compare it with another group of distribution since there is no standard value of a small or large value of IQR and QD. So we have to have another group or data set for us to compare our IQR and our QD. Because for a single data set, we cannot conclusively say that this IQR or QD is telling us about a wide or a narrow dispersion of the observation. That's why we have to have another group of distribution for comparison purposes. Now, mean deviation. Mean deviation measures the average deviation of the values from the arithmetic mean. It gives equal weight to the deviation of every score in the distribution. Mean deviation for ungrouped data. So we have this formula. Mean deviation or MD is equal to the summation of the absolute value of the individual observation or score minus the mean divided by the number of observations. So you have to get the mean of the scores and use that one in subtracting from the individual score. Okay. Then these are the steps in solving mean deviation for ungrouped data. We have solved the mean value. So that's the first step. Second step, subtract the mean value from each score or individual score. Then the third step, take the absolute value of the difference in each step in step 2. Then solve the mean deviation using the formula, this one. So it seems now that the process is getting a bit complicated. Okay. Then let's have an illustration. Find the mean deviation of the scores of 10 students in a mathematics test. So we are given here test scores 35, 30, 26, 24, 20, 18, 18, 16, 15, 10. The test scores here are arranged in a descending order. The highest score is 35 and the lowest score is 10. So there are 10 observations or 10 scores in this illustration. So in our solution, we have to get the summation of all the scores, then divide it by 10. So the sum of the test scores is 212 divided by 10, so you get 21.2. That's the mean. So this mean will be subtracted from each of the test scores. Okay? So then add the result. You will get 60.4 divided by 10, you get 6.04. So our analysis here, the mean deviation of the 10 scores of students is 6.04. This means that on the average, the value deviated from the mean of 21.2 by 6.04. So this time, the deviation is being referenced, no, or is used with the mean of the observations. So there's now a reference point. Oh, there's a reference point, and in this case, the mean, and we get the value of deviation from the mean, which is 6.04. Now, mean deviation for group data. So here, you have the summation of the frequency f times the absolute value of x sub n, this is the class mark, minus the mean divided by the number of observations. Okay, MD, mean division value, F, class frequency, X sub M, class mark or midpoint of its category, X bar, that is the mean value, then N, number of cases. Steps in solving mean deviation for group data. Now solve for the value of the mean. Subtract the mean value from each midpoint or class mark. Take the absolute value of each difference. Multiply the absolute value and the corresponding class frequency. Then find the sum of the results in step 4. Then solve for the mean deviation using the formula for group data. Example, find the mean deviation of the given scores. Now the scores are already grouped here. We have the table. And to be able to get the mean deviation, we have to get first the mean. So the mean is equal to the summation of frequency times class mark. So we have here 5 times 12, that is 60. Okay? So frequency times the class mark. Okay, so this is the product. Now, the summation is 1,345 divided by 40. So you get 33.63. Now, this mean will be used to subtract from each of the class mark. So we have this column. So we have 12 minus 33.63, that is negative 21.63. Then 17 minus 33.63, that is negative 16.63. So you have to do it until the last pair. Then you take the absolute value, so the negatives become positive. Then after that one, 21 times this one times the frequency, 12 times 21, you get this one. Then take the summation. So for the mean deviation, we have to use the formula, the summation of f times the absolute value of x sub m minus x bar all over n. So here we have 425.22 divided by 40. So our MD is 10.63. What does this MD imply? The mean deviation of the student's course is 10.63. This means that in the average, the value deviated from the mean of 33.63 by 10.63. So that's the meaning. Now, let's come to variance and standard deviation. The standard deviation is often used as a measure of volatility. The variance and standard deviation are measures of dispersion of data with respect to the mean. Variance is one of the most important measure of variation. It shows variation about the mean. Now, for the formula of population variance, you have sigma squared equals the summation of the square of x bar or x observation minus the population mean. This is mu, population mean, divided by the number of observations. Then we have the sample variance. It is represented by s squared, and that is the summation of the second power of the observation minus the sample mean divided by n minus 1. Remarks about the variance and standard deviation. If there is a large amount of variation in the data set, the data values will be far from the mean. In this case, the standard deviation will be large. If, on the other hand, there is only a small amount of variation in the data set, the data values will be close to the mean. Hence, the standard deviation will be small. Just like the mean, it is affected by the value of every observation, and it may be distorted by few extreme values. This would happen because every observation is used in the calculation. So extreme values would likely affect. It is always positive. Steps in solving variance of ungrouped data. Solve for the mean value. Subtract the mean value from each score. Square the difference between the mean and each score. Find the sum of the results in step 3. Solve for the population variance or sample variance using the formula of ungrouped data. Okay, for example, we have here an ungrouped data, and in this illustration, the sum of the observations is 146 divided by 10. You get a mean of 14.6. Now, you have here the mean, then this mean is subtracted from each of the individual score. So 19 minus 14.6, you have 4.4. 17 minus 14.6, you have 2.4. And after that, after having done all the getting of difference, you have to take the second power of this column. So 4.4 squared, you get this one, 19.36. 2.4 squared, you get 5.76. Okay, up to the last, this one, up to the last observation under this header. Now, take the sum. For this illustration, we have 60.4. Okay? So, to compute for the population variance of ungrouped data, we have to use this formula. So, all we have to do is substitute. For the numerator, you get 60.40 and n is 10. So, you have sigma squared is equal to 6.04. For the sample variance of this ungrouped data, the same, you substitute this numerator by 60.4. Then divide it by 9 because the divisor here is n minus 1. So you get 6.71. So the sample variance or S squared is 6.71. Note, if the standard deviation is already solved, square the value of the standard deviation to get the variance. So for this one, if this is the variance, if you take the square root of 6.71, that is the standard deviation. So that is just the inverse of what this note is telling us about. Variance of group data. Population variance is sigma squared, but this time we have to use the frequency, then the plus mark minus the population mean, then the second power of this one, then all over uppercase letter N, then sample variance. It just looks like the population variance, but our denominator here is N minus 1. Again, let us be clear that this uppercase letter N indicates that we are referring to the population variance, and this small letter n or lowercase letter n indicates that we are referring to the sample variance. Now, steps in solving the variance of group data. Solve for the mean value. So you get first the mean. Then subtract the mean value from each midpoint or class mark. Then square the difference between the mean value and midpoint or class mark. Then multiply the squared difference and the corresponding class frequency. Then find the sum of step 4. Then solve the population variance or sample variance using the formula of group data. Okay, so we have here an illustration. Okay, so we have here how many categories? 1, 2, 3, 4, 5, 6. So we have 6 categories. Okay, so the first thing that we have to
know is the mean. So you have this 1,348 divided by 40. You get a mean which is 33.7. Then 33.7 is subtracted from the plus mark 17.5. You get this negative 16.2. Then after raise it to the second power, you have this one. Okay? Then this one, 262.44, is multiplied by the class frequency by 3. And this is the product. Then get the sum here. You have 2,606.4. So we can now compute for the population variance. We simply use the formula. So this one, we're using this one for this. Okay? This is the summation. So you have 2,606.4 divided by 40. So that is equal to 65.16. So sigma squared indicates population variance. And if you are going to take the square root of this, if you are going to raise both sides by 1/2 or take the square root in both sides of this equation, you will get the population standard deviation. Then for the sample variance, you have this one, S squared. So the same thing, we have to use this 2,606.4 divided by 39. So our sample variance is 66.83. Okay. Standard deviation is the most important measures of variation. It is also known as the square root of the variance. So this is what I've told you. It is average distance of all the scores that deviates from the mean value. It is average distance of all the scores that deviates from the mean value. Now, population standard deviation, okay? So this is just the formula of the population variance, but we take the square root in both sides of the equation, so this one. Then the sample standard deviation, again, from S squared, it becomes S because we take the square root in both sides of the equation. So what remains at the left side is just the S. Okay. Here, steps in solving standard deviation of ungrouped data. Solve for the mean value. Subtract the mean value from each score. Square the difference between the mean and its score. Find the sum of step 3. Solve for the population standard deviation or sample standard deviation using the formula for ungrouped data. Note if the variance is already solved, take the square root of the variance to get the value of the standard deviation. By the way, these steps are exactly the steps of getting the population variance and the sample variance. That is why in getting the standard deviation, you have to get the population variance as well as the sample variance. And once you have the variance, you just take the square root, and that will become the population standard deviation or the sample standard deviation. Okay, let's have an illustration using the data on the previous example. Solve the population and sample standard deviation. So here, we already solved it. Okay, so the population variance in the previous illustration is 60.40. They divide it by 10. Then take the square root. You get 2.46. Then for the sample standard deviation, the same thing. The square root of 60.40 divided by 9. So you have the square root of 6.40 71. So you have S equals 2.59. So it's going to be easy once you have the population variance and the sample variance. Steps in solving the standard deviation of group data. Solve for the mean value. Subtract the mean value from each midpoint or class mark. Square the difference between the mean value and midpoint of class mark. Then multiply the squared difference and the corresponding class frequency. Find the sum of the results in step 3. Then solve for the population standard deviation or sample standard deviation using the formula for group data. Okay, so let's have this one. So population standard deviation of the previous example, that was 2,606.4 divided by 40. Okay, so we have 65.16. We have to take the square root of this number. So we have the population standard deviation is 8.07. For the sample standard deviation of group data, so we use the same illustration. So you have 2,606.4 divided by 39. You get 66.8308. So you have to take the square root for that. And you have the sample standard deviation. Interpretation of standard deviation. If the value of standard deviation is large on the average, the scores in the distribution will be far from the mean. Therefore, the scores are spread out around the mean value. The distribution is also known as heterogeneous. If the value of the standard deviation is small, on the average, the scores in the distribution will be close to the mean. Hence, the scores are less dispersed or the scores in the distribution are homogeneous. So the same interpretation about variance. Okay, it's time now to answer the questions we have at the start of this presentation. What can you observe about the mean and the standard deviation of the three groups? The answer is the mean of the three groups of scores is the same, which is equal to 18.25, and the standard deviation of section A is 5.15, section B is 6.92, and section C is 7.63. Then the next question, which group of students perform well in the class? In terms of performance, the three sections of students perform the same because they have the same mean value of 18.25. Which group of scores is most widespread or less scattered? So we have to use the standard deviation. So section A is 5.18, section B is 6.92, section C is 7.63. So the scores that are most scattered are those in section C. Section C has the highest standard deviation. Then on the other hand, the less scattered group of scores is in section A, which has the smallest value of the standard deviation, which is 5.15. Therefore, the smaller the value of the standard deviation on the average, the closer the scores are to the mean value, and the larger the value of the standard deviation on the average makes the scores scattered from the mean value. Using the diagram, there are more scores that are closer to the mean value in section A than in section B and C. Now we have here another illustration of mean. In this particular illustration, the mean is 65 and the standard deviation is 0. That is because all players have the same height. Then in the next illustration, heights of 5 marathon players in inches. Okay, the mean is 65, just as in the first illustration. But in the first illustration, the standard deviation is 0 because all the players have the same height. But here, the standard deviation is 3.6. That is because the marathon players have different heights or their heights vary. Then, in terms of the distribution of the observations in this diagram, again, we can see that they have the same mean for data A, data B, and data C, but their standard deviation differ. The smallest standard deviation is in data A, and the high data B, which is 1.414, followed by data A, and the highest standard deviation is in data C. Okay, we have here sample data. Then we have 8 observations. We have to take the sum of the observations divided by 8. You get a sample mean of 16. Then for the standard deviation, you have to subtract 16 from 10 and then raise it to the second power. Subtract 16 from 12 and raise the difference to the second power up to the last observation. Then divide it by the number of observation minus 1. So what you will get inside the square root symbol, the radical symbol is variance. But since you are going to get the square root, so this one is the standard deviation. Properties of variance and standard deviation. The most commonly used measure of variation, most especially in research. It shows variation of the individual scores about the mean. Relative measure of variation. So we are done with the absolute measures of variation. Now we have relative measure of variation. Coefficient of variation shows variation relative to the mean. It is used to compare two or more groups of distribution of scores, usually expressed in percent. The smaller the value of the coefficient of variation, the more homogeneous the scores in that particular group. On the other hand, the higher the value of the coefficient of variation, the more dispersed the scores in that particular distribution. The formula in computing the coefficient of variation is CV equals S, the standard deviation, divided by the mean times 100%. That's the coefficient of variation, where X bar is the mean value, S is the standard deviation. Let's have an illustration. So let's use the previous data. We have the scores of the students in section A, section B, and section C. We can see that they all have the same mean values, but they have different standard deviations. So to get the coefficient of variation, so for section A, we have the standard deviation is 5.15 divided by the mean of 18.25, then multiply that by 100%. You will get 28.22%. Then for section B, you have 6.92, the standard deviation, divided by 18.25, you get 37.92%. And for section C, you have 7.63, the standard deviation, then divided by the mean, 18.25 times 100%, you get 41.81%. Okay? The scores in section A are less scattered than the scores in section B and section C. In other words, scores in section A are more homogeneous than the scores in section B and section C. It can be also said that the scores in section C are more spread out than the scores in section A and section B, or the scores in section C are more heterogeneous than the scores in section A and section B. Measures of skewness. This is another very important topic because this will give us about the distribution of the observations. Measure of skewness describe the degree of departure of the scores from symmetry. The skewness coefficient, or SK, can be solved using this formula. SK equals 3 times the quantity x bar minus median divided by the standard deviation. Okay, so x bar is the mean value, then another x, which a crooked line, median value, then s the standard deviation. Skewness can be classified according to the skewness coefficient. If sk is greater than 0, it is called positively skewed distribution. When sk is less than 0, it is negatively skewed distribution. However, if sk is equal to 0, the scores are normally distributed. The skewness of a score distribution indicates only the performance of the students but not the reasons about their performance. So again, the skewness of a score distribution indicates only the performance of the students. Positively skewed or skewed to the right is a distribution where the end tail, thin end tail of the graph goes to the right part of the curve. This happens when most of the scores of the students are below the mean. So it is the tail of the graph which indicates the performance. It gives an idea. So for positively skewed or skewed to the right, it means that most of the scores of the students are below the mean. Negatively skewed or skewed to the left is a distribution where the thin end tail of the graph goes to the left part of the curve. This happens when most scores got by the students are above the mean. So we have here the illustration. This one, the thin and tail of the graph here is right here. So this is what we call positively skewed distribution. So you can see also that we have the mean, the median, and the mode. Then we have also the negatively skewed distribution. Here you have the mean, you have the median, and you have the mode. Okay, so this happens when the uh, skewness coefficient is less than 0. Example, find the coefficient of skewness of the scores of 40 grade 6 pupils in a 100 item test in mathematics if the mean is 82 and the median is 90 with standard deviation of 15. Here, we have to use the formula is k equals 3 times the quantity, the mean minus the median over the standard deviation. So we will have 82 minus 90, that is negative 8 times 3, that is negative 24. Divided by 15, you get negative 1.60. So our SK value is less than 0. This value of SK, which is negative, implies that the score distribution is negatively skewed. Most of the scores are high, and this means that the students have performed excellently in the said examination. Another illustration, find the coefficient of skewness of the scores of 45 grade 6 pupils in a 100 item test in biology. If the mean is 46 and the median is 40 with standard deviation of 7.5. Okay, so the same thing, we have to use the formula. So mean minus the median. So our mean is 46 minus the median, which is 40 divided by the standard deviation of 7.5. So we get 18 over 7.5. So is case equal to 2.4. So this is greater than 0. So the meaning is the score distribution is positively skewed. Most of the scores are below the mean. This implies that the students did not perform well in the said examination. Now, let's come to kurtosis. It is a measure of the tailedness of a distribution. Tailedness is how often outliers occur. Excess kurtosis is the tailedness of a distribution relative to a normal distribution. Tails are the tapering ends on either side of a distribution. They represent the probability or frequency of values that are extremely high or low compared to the mean. In other words, tails represent how often outliers occur. Now, these are the types of kurtosis. We have leptocortec distribution, mesocortec distribution, and platycortec distribution. When you say leptocortec, our cortesis value is greater than 3. If our cortesis value is 3, we call that one mesocortec. And if the cortosis value is less than 3, that is platycortec. So you can see the graph here that it is leptocortec, this one. The tail is right here. That's high. To calculate kurtosis in statistics, you can follow these steps. Compute the mean or the population mean, mu. Calculate the arithmetic mean of the data set. Compute the variance. Calculate the variance of the data set, which is the average of the square differences from the mean. Then compute the standard deviation. So you just take the square root of the variance. Then compute the fourth moment. Calculate the fourth moment of the data set, which is the average of the fourth power of the differences of the mean. Then compute the kurtosis. You have the formula mu 4 over Q4. Or have this formula. Now, let's discuss proportion. Proportion refers to the number of elements belonging in the category of interest divided by the total number of elements in the collection. So, proportion equals number of observations belonging in the category all over total number of observations in the collection. Example of proportion. Proportion of male students in the class. Suppose there are 30 males in a class of 50. So proportion counts of male students in the class, counts of all the students in the class. So you have 30 over 50, or that is 0.6, or that is 60%. Now, percentage. Percent means per 100, by the 100, or out of 100. A proportion can be converted to a percentage by multiplying it by 100. Example of percentage. Percentage of barangays in Sagay in the province of Camiguin. Since there are only 9 barangays in Sagay and the province of Camiguin has a total of 58 barangays, then we have 9 over 58 times 100, that is 15.52%. This means that 15.52% of the barangays in Camiguin are in the municipality of Sagay. Ratio. The ratio of a number x to another number y expresses the size of a measure x with respect to the size of another measure y. It is written as x is to y and is read as the ratio of x to y. In expressing ratios, it is best to write official statistics as ratios using either the base of 1, base of 10, base of 100, 1,000, or higher than that. Guidelines on ratio. So we have to consider this one. Avoid decimals in ratio. Avoid decimals in ratio. Given the following ratio, 1.3 is to 1 and 456.88 is to 1, you can write 1.3 is to 1. You change that. You can have it 13 is to 10. So base 10. Or you can have base 100. So you can change that also to 130, or 130 is to 100. Or round it off to a whole number. So 456.88, you can write that one as 457 is to 1. So we have to be observant of the guidelines on ratio. Resulting ratio must summarize the initial information. Example, a certain school has 5 males and 7 females. What is the ratio of males to females? So, since it is the ratio of males to females, so we have 5 over 7. And the decimal equivalent is 0.71 is to 1. This implies that 0.71 males for every 1 female. Since ratio must not have decimals, we have to change the base to 100 to make it a whole number. That is 71 males, or 71 males for every 100 females. So that's the meaning. Rate. Occurrence of events over a specific interval in time. The count of a certain variable of interest in relation to the population exposed to the event. Rate is a special type of ratio. Example, maternal mortality rate, birth rate, survival rate, enrollment rate, etc. Example of rate. The number of police personnel assigned to every 100,000 Filipino citizens in 2022. So total number of police personnel of all over total population in 2022 times 100,000. So you have 160,000, the total number of police personnel, all over 109,035,343 times 100,000. So we get 146.5 741. So, this implies that there were 147 police personnel assigned to every 100,000 Filipinos in 2022. Percent change. Percent change, it is equal to new amount minus original amount all over original amount times 100. When the new amount is larger than the original amount, the number on top will be a positive number and the result will be a percent increase. Otherwise, the percentage change is negative and is called a percent decrease. Now, this percent decrease happens if the new amount is smaller than the original amount. Example of 1% change. Suppose student A got ratings of 85 and 90 in the first and second quarters, respectively. Find the percent change in the first two quarter ratings. Solution. So, second quarter rating is 90, first quarter rating is 85. So, the new rating is higher than the previous rating. So we have 90 minus 85 all over 85. So you have 5 over 85. That is 0.0588 times 100. You have 5.88%. So there's a percent increase. Now, percent versus percentage points. Suppose you encounter the following news item. Interest rates jump from 5 to 8%. Question. Would you say interest rates increase by 3% or by 3 percentage points? Okay. So recall this problem. Suppose student A got ratings of 85 and 90 in the first quarter and second quarters respectively. Find the percent change in the first two quarter ratings. So solution, we have what we got is 5.88%. So from the result above, we can say that the rating increased by 0.88% or rating increased by 5.88 percentage points. So either of the two is correct. Recap. So these are some of the terms that we should remember: mean, median, proportion, ratio, change, percent change, and I think that would be all. Thank you for watching.